Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Hello everyone, and I am so excited that you are here. Welcome to my course Complete Linux Security and Hardening with Practical Examples. Now this is a course where you will learn everything about Linux security. Now when you finish this course, I'll tell you this, you will be able to go into your corporate world if you're already in IT, and you could go and apply all those security measures that I have covered in this course. And you'll be able to secure your system so no hackers could get into your environment. Now, if you are not in IT and struggling to find a job in Linux, this course will definitely help you add into your profile and get you a job a lot faster. My name is Imran Afzal, and I'm in IT for almost 18 years. And I have been with so many Fortune 500 companies. I've been with tech media industry, financial firm, fashion industry, cloud computing company, you name it. I have studied in New York City with Baruch College and New York Institute of Technology. So what I'm offering you today is this course which will help you change your skills in Linux completely. So what are you waiting for? Let's go ahead and click and enroll.
Hello everyone and welcome to my course Complete Linux Security and Hardening with Practical Example. I have broken down my entire course in 10 different sections. So let's see what's inside of this course. The first section will talk about the introduction and course overview, and in this section you could of course download your entire syllabus and review it anytime you want. Then moving on to section 2. This is about security concept. I'll cover what is security and OS hardening. What are we learning in this entire training? We'll do some comparison between house security and computer security, so it will be so easier for you to understand how important as computer security is. Securing all operating system, importance of Linux security, security tools and implementation of those tools, types of security breaches when a hacker comes in, what does he or she wants, how the person can breach the security, and what are the different ways. Every section that I have in this entire training will have quizzes, handouts, and homework for you to do. Moving on to section 3, this is a lab setup. We'll talk about virtual machine, installing VirtualBox, creating virtual machine, and doing the Linux installation. And of course, for those who already have a Linux lab running, you do not really have to go through the entire section 3. You could simply skip this, and this is completely optional. Now moving on to securing user environment. We'll talk about etc password, etc group, etc shadow. Now you're probably thinking, hey, we already know that. You probably already know that, but believe me, once you get to these lectures, you'll know there's so many things in these files that you probably never thought of, and that I will uncover for you. We'll talk about etc login.default file. What are the different things we could do when you create a user? You can make changes in that file. Create user account and change password. Changing password parameters, set password policy, lock or disable user account automatically and manually. Lock user account after 3 failed attempts. Moving on to section 4, restrict root login, disable SSH access for a specific user. UID, GID policies, centralized authentication services, sudo access, monitor user activity, and so much more in quizzes, handouts, and homework. Then getting into section 5, which will talk about PAM. What is PAM? You guys have heard of PAM, I'm sure, many times, pluggable authentication module. But I have created an entire section on PAM, so I will take my time and make sure that you understand what PAM has to offer. We'll talk about the importance of PAM, the configuration files format, the PAM config files module interfaces, account access through PAM config files, which has control flags and has modules. Then we'll talk about PAM aware services and stacks, and then we'll test your knowledge of what we have learned in the entire section of PAM. Moving on to section 6, which will talk about securing a file system, and that is Linux file types, file attributes, how we could change ownership and permissions, changing file permissions, changing file ownership. We'll talk about control list, which if you want to be more specific on the permissions, we'll use control access. Access control list. And then getting on to section 7, securing Linux system. Now we are getting into deep inside of the system level, where we'll talk about message of the day and customizing message of the day. We'll talk about how displaying the message can actually secure your system. Physical server security, we'll get into the labs where we'll learn how we could remove unnecessary or orphan packages, keep kernel and system up to date, stop and disable unwanted services. We'll talk about creating disk partitions for every file system we have, so we could keep our partitions secure in case our hackers get into our system. We'll talk about disable control alt delete keys, running one service per system, and moving on to section 7, change default console password, disable USB stick detection, enable NTP or cron ed, lock down cron jobs, change SSH ports, SE Linux. I have included SE Linux in this section 7. Now please keep in mind SE Linux, this topic within section 7 is the longest lecture and has so many practical labs that I have included. So don't think that SE Linux is just one lecture. This is probably like 35-40 minutes lecture where you will learn everything about Linux and in very simple language. We'll talk about how you can perform backups that can secure your Linux system, and quizzes, handouts, and homeworks to test what you have learned. Section 8 is about securing Linux system network, meaning firewall, IP tables, practical examples, and we'll also talk about Firewall D practical example, and Firewall D GUI. Everything about firewall. So I have covered IP tables, which is used in many systems today. Will talk about Firewall D, which is a newer version of firewall, and I will have also talked about the Firewall D, managing Firewall D through GUI. This entire section is filled with firewall and securing Linux systems network. And believe me, this is where you will learn everything inside out of IP tables and firewall. And then we'll talk about encrypting incoming and outgoing traffic, SSH versus Telnet, turning off IPv6 only if it's not in use, and of course quizzes, handouts, and homework. Section 9, securing environment around Linux. We'll talk about hardware network firewall. And now this firewall is not the Firewall D or not the IP tables. This firewall is about the firewall that runs on its own dedicated hardware appliance. Network address translation, NAT, VPN tunnel, application database encryption, and the end, you know what those things are. So section 10 I have included as an additional resources for you if you want to learn more. What are the things you're gonna learn, like getting help on the commands, compress and uncompress files, changing passwords, set command, talking to users, user directory authentication. We'll also talk about different authentication directories like AD, OpenLDAP, WinBind. We'll talk about system log monitors, root password recovering, file transfer commands, NIC bonding, advanced package management, and much, much more. So now, after going through the syllabus, you ask yourself, is this the right course for you? And if your answer is yes, then just go ahead and click on enroll. What is security and what is OS or operating system hardening? Let's talk about security. Hey, isn't the security everybody knows about? Yes, it is, and it is that simple. But let's go over a quick definition of what security is. Any type of protection against harm, right? So you have a house, you want to protect your house. You want to protect yourself, or you want to protect your computer. Anything or any type of protection against harm is defined as security. So what is a computer security then? Well, in Wikipedia language, or in a very formal language, a computer security, cybersecurity, or information technology security is the protection of computer systems from theft or damage to their hardware, software, or electronic data, as well as from disruption or misdirection of services they provide. Now, the first part is very simple, that you want to protect your computer from a loss of hardware or software, and of course the data itself. But the second part says it's also a security to protect against the disruption or misdirection of the services they provide. If your computer is providing any type of services, so if it is under attack, or there's a breach to your computer, then not only your data will be gone, then most likely your function of your computer will also be impacted. So computer security is also designed to protect your services as well. Let's talk about Linux security. Linux security. Now, Linux is an open source or open source operating system whose code can easily be read by the user, but still, it is more secure operating system than compared to many other operating systems. Okay, perfect. So if it is more secured by any other operating system, then why do we need a Linux security? The need of Linux security arises for basically two reasons. One is internal, meaning you do not have access to the outside world, but still you want to protect your computer against damages or against mistakes. So if you have a local user environment that people log in, whether it's QA and whether it's DevOps, or even yourself, if you are a computer system or Linux system administrator or engineer, you could make mistakes as well. So you want to implement some kind of local security. When you make a mistake, that mistake either first does not happen, or second, if it does, then how you could correct that mistake. So that's an internal security that you could implement. Second, or external type of security, or the need for the security of Linux is external. If your Linux computer is servicing services such as HTTP, FTP, NFS, or anything like that. By the way, I mistyped that FTP twice. What I meant to type is NFS. But anyway, so any services your computer is, or your Linux computer is servicing, that service is actually interacting with users from outside or out on the internet. Then you definitely need some type of security on your computer, around your Linux computer. Let's talk about OS hardening. What is OS hardening? And what is the difference between OS hardening and security? Well, OS security and hardening used interchangeably. There's no difference between them. Mostly hardening is used in a Linux environment, whereas security is used in mostly all other operating systems. In simple words, hardening is used when making the operating system so hard to break. So you will make your Linux operating system so secure and so hard by implementing certain principles, certain rules, that it will become so hard to break. So when someone asks you, hey, have you done OS security on your Linux computer environment? That yes, security and hardening is pretty much the same way. So we'll cover more topics about Linux security and hardening in the later lecture. Let's keep going on. Let's talk about types of security breach. We will talk so much about how we could secure our Linux system, but before we get into that, let's talk about what are the different ways the security can be breached. The first one is about data. So data is the number one security breach. Anyone who hacks your system or invades it, or breaks the security barrier, they want the data. And as I said before, the whole IT is about information, and that information is secured and saved in data. So when the data is breached, they could be that could be stolen, it could be corrupted, or it could be removed from your entire system. So data is the number one security breach. Then moving on, the application. The application security breach, meaning all the application or the software that is running on your operating system. When someone hacks your system, and they cannot get to the data, then the second target would be the application, meaning they will disable or they will dismantle the application that actually processing the data. So that could be like an Apache server. If you are on a retail industry and you know you make millions of dollars in a day on a retail, and especially during the day during the holiday season, and bringing down your Apache server, which is actually the front end of your system that is taking all the requests, will actually impact your revenue. Another example of application would be the database. So you're running Microsoft SQL or Oracle database or Informix, any type of data. So the attack could be on your database. Then the financial application. If you are into a financial world or if you're running on financial, you've probably seen so much security around it. So they have applications that are actually crunching the numbers. What will happen if those financial applications are brought down? Well, this will disable the entire financial sector. So that's why every time an invader or hacker tries to get into a machine, they will try to attack those financial applications. Then moving on, the third type of security breach is this operating system. So if a hacker cannot get to the data or applications, then they get to the operating system, the system that is actually facilitating the entire process, the system that is saving the data, the system that is providing the resources. So that could be file system corruption, or it could be a complete system failure. Your whole system is down, or the process management. Anything that runs on the memory or CPU processes that is actually handed over from one place to another, that could be impacted. Then the last one is the hardware system security breach, where someone would actually attack your hardware and actually attack on your CPU, your memory, or your system peripherals, and actually disable or remove or actually corrupt your system peripheral devices, and those are so important for your system to run or function. So there are a few of the security breach that we need to talk about, and we have actually listed all of them. We need to make sure all of these data application and operating system hardware are protected. And how are we going to protect them is everything that we will talk about in the coming lectures. Now let's look at securing all operating systems. When we say securing all operating systems, we're talking about securing them in a corporate environment. Of course, if you are using a Linux operating system at home or in a very small type of environment, you only have one machine, then you only are concerned of securing that specific operating system, whether it's Linux, Windows, or whichever operating system you're using. But if you are in a corporate environment where you are working with multiple servers and databases and applications, then most likely you're working in a tiered type of environment where you have some type of databases running on Windows, or you're running the web servers on Linux, you're running the WebLogic, the application piece on Oracle or Solaris. This type of mixed different operating system environment is actually the corporate type of tiered environment. So it is very important when you have this type of environment, you need to secure all the operating system around it. So let's say if you're supporting a retail company, right, and they have a web servers that is the front end of the company where people will come in and make the purchase. Most of the time, the web servers they run on Linux. So they are running, that's a front end, and the back end is running on Solaris or Oracle, which runs, let's say, WebLogic application, or maybe it's also Linux. Again, depending on the corporate what they choose. And then the third tier would be the databases where all the information is stored. And sometimes people use Microsoft SQL and Formex and SQL, different type of SQLs databases. So anyway, they all run a different operating system. If you change it around, maybe the Windows is the front end, Linux is the middle, and the last one is Solaris. Anyway, what I'm trying to say is any environment that you're working on that consists of multiple operating system, you just not only have to secure that specific Linux system, you have to secure every other operating system that it deals with as well, because it's possible if it's Windows is the one that is facing the internet, that is getting the virus or being attacked, and it's being passed through Windows to Linux. So no matter how much secure your Linux is, you're still getting the virus from Windows. Similarly, if you have Solaris server or Oracle server in the end, and you have all the security patches and everything implemented on the last tier, which is right here, and you have not done a good job on Windows or Linux side, then eventually you are compromising the Solaris operating system. Anyway, to put everything in a nutshell, make sure all the operating system in the environment are actually secured as well. Okay, I'm going to quickly compare how the house security works against the computer security, meaning how we could compare apple and oranges, right? So let me give you a quick example. We have a house, right? Inside of our house, we have items that we actually secure. Items like our valuables, jewelry, cash, TV, or even furniture. We secure those in the drawers or inside the suitcases, and each of them has a key. Then we have a bigger security at the room level. So each room in your house has a door, and door has a lock that you need a different key that is completely different from your actual main door. So your windows are locked too. That's another security. If you open up your window and you lock your door, that's definitely a hole that anybody could get into your room. Now at the bigger level, we have our house security. That house security applies the entire house, and you give the key to your house to someone that you trust or your loved ones, so you trust them when they get in. However, there might be people that you give your keys to the house, but you not give them the keys to your rooms, or you do not give them keys to your drawers or briefcases. Then we have a bigger picture, a neighborhood security, where you live in, let's say if you're living in a community type of environment where there's a gates, a watch, a night watch, or there's a gatekeeper who's looking after who's coming in and who's leaving. So let's compare to our computer. We have a data center where we actually physical data center where the computers are racked and stacked. You need access or some kind of security key or badge to get into the data center. Then we have a hardware where when you see at the actually hardware level, you see there is a key in front of every computer. When you unlock the key, then only then you could remove the front panel from the computer and access the CD-ROM or hard drives. Then coming down to the operating system, this is the main topic we're discussing here. Operating system, which is our Linux operating system. We're gonna work closely to securing the operating system. In our example of home security, our entire house is like an operating system where we have access to the doors, to the rooms, and all other different rooms inside the home. We could lock down the accounts as well. Then coming down, we have applications and users. This is more like a comparison to like items, where we run the application, which application needs what type of access, which user needs which home directory access, which file they could access and which file they cannot. Just like which user in your home or which person in your home can access your drawer or can access your briefcase. So this is a pretty big comparison that I've given you that compares our home security to the computer security. Again, our focus is the third circle in the middle, which is the operating system, and we will cover exactly what are the measures we're going to take to protect our operating system. Importance of Linux security. We're going to spend so much time talking about Linux, how we could secure the Linux operating system. But first, let's take a look at why it is so important to put a security around Linux. So, the first thing that we need this Linux security is to protect our data. So, data is the most valuable thing in the computer or in IT world, and everything we do in IT is about data. So when you say IT, it's information over technology. So what is that information? That information is saved in terms of as data. So we need to protect that data, and that's why we need a Linux security or any type of security where that data is sitting, whether it's Windows security or Solaris security. But security around operating system is the primary reason is to protect that data. Second is to protect the system resources. So of course you're gonna get attacked by people who would actually attack your server. They could actually attack specifically through your memory or to your CPU or directly to your disk. So where all these resources become inoperable. So when you cannot, or when your memory or when your computer memory or CPU or disk cannot function, or they get infected with the virus, what happens? Then you lose your workflows, your application workflows. So you need to protect your application workflows as well. And those workflows run with the help of memory, CPU, disk, and many other computer resources. So computer resources in the background are working hand in hand just to make sure the applications that run on top of them are supported. Then another important thing of Linux security. Now keep in mind all these Linux security, the importance, why do we need it? All of these that I have listed here are through my personal experiences. If you go on Google or any search engine and type importance of Linux security or why do we need Linux security, most likely you're not going to find anything. You're probably going to find so many of Linux security tips and tools that would tell you how to secure Linux, but you're not going to find why do we need to secure. So I'm listing all these topics, all these big points here to make you understand the importance of having Linux security. Anyway, moving on, the fourth and the most important of having Linux security is because of the audit compliance. We do get audited, or companies do get audited, and every time they get audited, they have to provide how they are protecting the customer if they have any customers, or how are they protecting the data, or how or what type of practices they have in place to protect their resources. There is something called SOC, which stands for Service Organization Controls. Also, maybe you have heard of SOC reports. The SOC reports actually became effective on June 15th, 2011. Now, these reports can be requested by government or by your clients or anybody external to your company or even your board members. So if you're running a company, let's say ABC, anyone who is actually has any type of involvement or has any incentives that is vested to or in your company can come in and request that SOC reports. So because we need to have those SOC reports are generated based on all those Linux security standards. Moving on, we need Linux security for less human errors. So we don't make any mistakes. We make things so secure. Even if even if I fat finger or mistype something, we will make less errors. Then control management, of course, security is implemented so we make, of course, less mistake and we give the control to who gets what or who can access what. So let's say if I want John to log into this machine, and I don't want John to not log into this machine. Why is that? Because of the security concern. If I want John to access this file and I want John not to access the other file. Why? Because the John does not have privy or is not privy to the other file, and he could only view the other file. That is also a security mechanism we put in place. Then, of course, in the end is the peace of mind, which is what everybody needs when you have security around. Just like I explained earlier, when you have locks in your house, when you have locks in your drawer, everything is secure. You sleep good at night. Why? Because you have that peace of mind that your house is secured. Just like that. When your environment, when your computer, your Linux environment is secure, your manager, yourself, or anybody who is involved in Linux security will be sleeping really nicely at night, and of course will have a peace of mind. These are the few Linux security tips, or not the tips, Linux security importances that I wanted to discuss, and as I said again, all of them are based on my own experiences. Okay, we have talked about how important it is to implement security in our environment. But now let's talk about what are the different tools or different ways we could implement the security. First one is through the manual security configuration, meaning you log into the system manually and you configure and apply all the security measures manually one by one. And those measures are user accounts, meaning which user account should be created, who should get what access, what type of limitation they should have on their accounts, file systems, system access, who should be accessing the system. By the way, for the file system, who should be accessing which file, which directory, and coming down to system access, who should or who is allowed to access that system, or who is allowed in that system to go outside and where. Then system security, like the system itself, whether it is the security around process, security around disks, security around CPU, memory, how it is accessed, or how you want to change the behavior of a kernel. All that security can be implemented through the system configuration files. Then the OS network layer security. So at the network side, because when you run ifconfig command on your Linux machine, you will see the network ports and the network IP addresses. That's where the traffic leaves your machine and traffic comes to your machine. And there are actually security you could implement around it, like firewalls and the IP rules tables. There's so many of them that we could talk about it. By the way, all of these listed here are the manual security configuration that you can apply. And there's so many others that we will talk about in this entire training. So the first point that I'm trying to make is it's through the manual security configuration where you log into the system, go through each configuration file or whichever the security measures that you want to take and apply it. Then the next one is automation through the script. So what do? All the steps that I have listed above, you put it in a script. You log into that machine, you put the script in there, or you copy it there, or you access it through NFS or Samba, or whichever way you access it. Then you execute that script. So create it, copy over, and then execute it. If you have multiple servers, then you could perform that script execution on every server one by one. Now, a lot of people have actually followed this if they have multiple servers. Of course, you don't want to log into every server one by one and then do the manual configuration because that task is tedious, and the automation piece or to script it is one of the major or biggest tasks of a system administrator who should do that. Then the deployment tools. Nowadays you have heard of tools such as Ansible, Puppet, or Chef. These are the tools that are available to you. So the way it works is you set up a new virtual machine or a new system, whether it's physical or virtual. You put that virtual machine's keys, the security keys and IP, to that tool, the Ansible Puppet. Then that tool has that built-in automation scripts, and it will execute it against all those servers that you specified. So of course you need some experience around Ansible and these tools to work on it. Then the last one, the security implementation tool, is through the third-party security software. Maybe there are tools out there that would provide all the security measures that you see above there, but every environment is different. If you are working for ABC and the other person is working for XYZ, you probably have a different way of securing your users as the other person who's working for XYZ. So maybe the third party tools are not the ideal tools for everyone. The third party tools are best for people who want to actually implement security, predefined security that comes with it, such as a software like McAfee. They have a predefined security measure tools that are built in. When you install it, it actually protects your system against the outside invasion. So you don't want someone else or someone from the outside to actually um, log into your system or invade your system. So these are the type of security tools that helps you protect against the security breach. So again, not ideal for all security measures. If you are going through the manual steps that we have listed above, then this third-party software tools does not work. Anyway, to summarize it, manual security, automation through the scripts or through the deployments tools. And of course, you could use a third-party software as well. Hello everyone and welcome to our lab setup section. This is a section where we are going to actually set up our lab. A lab is where we are going to perform our certain troubleshooting tasks. Because this training is all about troubleshooting, right? And we need some type of operating system, specifically Linux, where we could perform troubleshootings. So how we are going to set up a lab. So this is what I'm going to cover in this section. The first thing we will do is we will cover the virtual environment. What exactly a virtual environment is, how a virtual machine runs on a physical machine, how multiple virtual machines can run on one physical machine. Then I will cover the Oracle VirtualBox, meaning there are so many other virtualization technology, for example, VMware, Microsoft Hyper-V, Citrix virtualization, Red Hat virtualization, there are so many of them. I am picking Oracle VirtualBox because it's very simple, straightforward. If you prefer any other virtualization technology, please be my guest to use that. Then the next topic we'll cover is about installing Oracle VirtualBox. I will take you to the website of Oracle VirtualBox. We will together download the software. Once the download is completed, it will go through the installation and the configuration of Oracle VirtualBox. That Oracle VirtualBox will allow us to give us a platform where we could run virtual machines. So the first next step would be is to create our first virtual machine once we have the Oracle VirtualBox set up. That virtual machine will be set up for our Linux environment. So the next step would be is to install Linux on that virtual machine. And the Linux that I have picked, the flavor of the Linux is CentOS. Now CentOS is similar to Red Hat, and Red Hat has the biggest market share in corporate environment. That is why I am picking Red Hat or CentOS operating system for this entire training session. So one thing I do want to mention, if you already have a lab setup, or if you already have a machine, a virtual machine or physical machine that is running Linux, whether it is Ubuntu, CentOS, SUSE, or any other, and that you want to prefer to use it for this entire training session, then just simply skip this section because you don't need to set up the lab, you don't need to set up the Oracle VirtualBox, you already have a Linux machine. If you do not, then simply go through all these steps and let's get started. What is Oracle VirtualBox? And of course, why do we need to know about VirtualBox? Well, for this course, you do need to install CentOS Linux operating system on your computer, and there are two ways you could install it. One, you could remove the existing operating system that you have on your computer, or you could install VirtualBox on top of your existing Windows operating system or Mac, and then you could install CentOS, so this way you won't lose anything. So basically, VirtualBox is a free and open source hypervisor for x86 computers currently being developed by Oracle Corporation. It installs on your existing Intel or AMD based computers, whether they are running Windows, Mac, Linux, or Solaris. It extends the capabilities of your existing computer so that it can run multiple operating systems on one hardware at the same time. Let's see how it works. So you have when the hardware layer, and then on top of it you install the operating system. Of course, it could be any one you have, that is Windows or Mac. And then you install Oracle VirtualBox. It's just a program, a software that you install on your machine like any other software that you would install. Once you have installed Oracle VirtualBox, then you could install Linux on it as a separate small version of operating system. You could have Windows on it, or you could have Mac on it. So this VirtualBox allows you to have multiple operating system on a same hardware. What is Oracle VirtualBox? And of course, why do we need to know about VirtualBox? Well, for this course, you do need to install CentOS Linux operating system on your computer, and there are two ways you could install it. One, you could remove the existing operating system that you have on your computer, or you could install VirtualBox on top of your existing Windows operating system or Mac, and then you could install CentOS, so this way you won't lose anything. So basically, VirtualBox is a free and open source hypervisor for x86 computers currently being developed by Oracle Corporation. It installs on your existing Intel or AMD based computers, whether they are running Windows, Mac, Linux, or Solaris. It extends the capabilities of your existing computer so that it can run multiple operating systems on one hardware at the same time. Let's see how it works. So you have when the hardware layer, and then on top of it you install the operating system. Of course, it could be any one you have, that is Windows or Mac. And then you install Oracle VirtualBox. It's just a program, a software that you install on your machine like any other software that you would install. Once you have installed Oracle VirtualBox, then you could install Linux on it as a separate small version of operating system. You could have Windows on it, or you could have Mac on it. So this VirtualBox allows you to have multiple operating system on a same hardware. Hey folks, and welcome back. In this video, we are going to download and install Oracle VirtualBox software. So, if you go through step by step, the very first step is, of course, we have to open up your internet browser and visit www.virtualbox.org. Then the next step is go to its download page and find where is the download page on the navigation bar, and then you will see the most recent software that you could download. All right, once the software is downloaded, the next step is, of course, to execute it and go through the installation and configuration procedure of the software. Okay, very simple and straightforward. So let's start up our browser. Now, of course, pick the browser of your choice. I'm going to go with Google Chrome. So I'll go type Chrome. And here I will type it in www.oracle, sorry, virtualbox.org, and it will bring me to this page. Let me move this up. All right, this page will give you the welcome to virtualbox.org, some information about it. I want you to go to the navigation pane and right here click on downloads. Okay, when you are on the download page, right here it says VirtualBox 7.0.10 platform packages. Now, depending when you are watching this video, the version might have changed. So it doesn't really matter if the version is changed to a higher version. All you have to do is download this virtual software, the most recent one. Okay, then which platform? Are you using Windows machine where you're going to be downloading this? Then yes, click on this one. Are you using Mac? Are you using other Linux distribution or Solaris distribution? So for us, in our case, we have a Windows machine, so we'll click on Windows host. Okay, once you click on it, it will start the download, and of course, the download process is very fast. It has already downloaded, see right here, and it downloads to my desktop. Okay, so now where is my desktop? So let's go to my desktop. All right, right here on my desktop, you see this is the executable file that it has downloaded. Now go ahead and double click on it so it could start the installation procedure. All right, the first thing is, do you want to allow this app to make changes to your device? Yes, of course, because we want to go through the installation. Okay, next step is welcome to the Oracle VM VirtualBox version setup wizard. This setup wizard will install Oracle VM and so on. Click next. Okay, select the way you want features to be installed. I want you to leave everything default. Now, you could customize it depending on your requirement, but again, since we are doing it for the first time, and this is for our lab, we're gonna leave everything as is and just simply click on next. Warning, network interfaces. Installing the Oracle VM VirtualBox in networking feature will reset your network connection and temporarily disconnect you from the internet. Proceed with installation now. Now, before you click yes, make sure you're not running any type of important downloads or program in the background that will interrupt the network connectivity. If it is, go stop it and then come back and then do click yes. But of course, again, this is a lab. We know we are not running anything, so go ahead and click yes. Missing dependencies, Python core. If you're getting these messages, that's fine. It will install these dependencies as well, so click yes. All right, begin installation, ready to install? Yes, go ahead and click yes or install. Okay, Oracle VM VirtualBox 7010. Please wait while the setup wizard installs Oracle VM VirtualBox. This may take some time. Of course, for me, it's took literally like 15 seconds. All right, Oracle VM VirtualBox installation is complete. Click Finish, Start Oracle VirtualBox. If it's checked, then it will start the program right away. So click Finish, and it will start the Oracle VirtualBox application right now. All right, let's see if it is running on our tray or task manager. Yes, it is. See right here, it is running. Okay, so here it is Oracle VM VirtualBox. This is how the Oracle VirtualBox after installation, the portal will look like. Now, this portal allows you to create a new virtual machines, add existing ones if you already have it, import it, export it, and all these features you could go through one by one and understand. But of course, our main focus of this course is not to learn the virtualization software, but to actually learn Linux. So I'm going to leave that little piece of learning with you. If you want to explore more, go through it and learn it. But for now, we'll stop here and we'll go to the next video. In the next video, we will go ahead and create a new virtual machine so that virtual machine can have Linux operating system on it for our lab environment so we could practice Linux commands on it. Hello and welcome to CentOS installation. This is the fun part. Yes, this is where we're gonna get our hands dirty. We're gonna go ahead and download the CentOS ISO image file from the internet. Once we have it downloaded, then we will go through the installation, a complete installation of CentOS Linux operating system. So are you ready? So now I want you to go ahead and open up your browser, any browser that you prefer, whether it's IE, Firefox, or Chrome. So let's go in. I have my browser open already. Um, I will go into Google. Now, the second step is you could use Google or any search engine that you like, and I want you to type CentOS download and hit enter. Once you hit enter, you will get the first link. I want you to go ahead and click on it, or you could simply go ahead and click on download. But first, let's go to this first link. So on the first link or the first page, you will see download CentOS. Now, sometimes you will see three options in this page. One is a DVD ISO, second one is everything DVD ISO, and third one is minimal. You might also see CentOS Linux DVD ISO or CentOS Stream DVD ISO. Again, the website changes the way it looks time to time. What you need to pick the one that has a Linux DVD ISO. If you are seeing three or if you're seeing two right now, it doesn't matter because what we need is DVD ISO. So go ahead and click on DVD ISO. This will bring you to the links where the ISO images are saved. So go ahead and pick any one of your choice. I will recommend that you pick the first one. Now, if your screen shows CentOS version 8 instead of version 7, then it's perfectly fine. You could go ahead and pick version 8 because version 8 installation is very similar to version 7. Once you click on the first one, it will ask you or prompt you to save the file. You have to save the file to the location, so go ahead and click OK. If you do not know where the file is being saved, you see this little arrow here. If you are using the Firefox, you will see this little arrow here. Click on it and it will tell you that it is being downloaded right now. I do not want to download because I have already downloaded that file previously because I don't want it to waste time, your time and my time to go through the complete download. So let's minimize this page. Let's go to our desktop because all my downloads go into my desktop. Now you already have the CentOS file. Okay, now I want you to go ahead and click on or double click on your Oracle Virtual Box, the icon you have on your desktop. If you do not have that icon on your desktop, then you go to the start menu and find that up, and you will go ahead and start from here. When it opens up, you will see the My First Linux VM, the one we created earlier. These two, you're probably not going to see it because I was playing around with some Windows virtual machine. Anyways, you could just ignore them. Click on the My First Linux VM and click on Start. Now this is powering up your virtual machine. This is exactly the same way as if you powering on your physical machine by pressing the button on it. So now it is asking, since this virtual machine has no operating system, so by default is asking you to attach a virtual disk to it. So it is asking where is the location of that virtual disk which you want to install that operating system. So go ahead and click on this little icon which will browse us to our desktop where we have our ISO image saved. Click on this little one and you will see right here on our desktop folder, when you click on our desktop, you come down and you will see right here it says CentOS 7, which we have downloaded a few minutes ago. So go ahead and click on Open and click on Start. By the way, this top thing right here is telling you have option to capture keyboard option turn on. This will cause the virtual machine to automatically capture. You could just go ahead and cancel it. Now it's telling you at this screen, it's telling you this is a CentOS 7. Install CentOS 7, test this media and install CentOS 7, or do the troubleshooting. Right now, by default, Test this media and install CentOS 7 is selected. You do not want to test this media. Usually this option is picked when you have a DVD install. And the reason we do the test, because sometimes the DVD have scratches on it. That's why we wanted to go through the test. So since this is ISO image, we don't do that. So go ahead and hit up arrow key on your keyboard, and it will select or highlight the top one. It says install CentOS 7. And now go ahead and hit enter. It is actually bringing the ISO image, copying the files that are needed to actually install the operating system. So it will go through certain startup processes. It will start up the GUI that will allow us to go through the installation of the Linux CentOS operating system. We will give it a minute for the GUI to come up. See right here, it says starting installer, one moment, and the installer, the GUI itself, is called Anaconda. This is the name they have given. Why? I don't know, but this is the name. If you wanted to keep in mind, you just remember that Anaconda is the GUI tool or the GUI wizard that will help you to install the Linux operating system. Now you are on the welcome to CentOS 7 welcome page. What language would you like to use during the installation? By default, English, and I am in United States, so I'll pick English, United States. If you are in any other country, I will recommend that you pick that country, or if you want to pick a different language, you could pick that. However, I am not going to tell you how you could go through the installation with different language. Anyway, so I would prefer that you stay on English, and then you could pick a different country. Now go ahead and click on continue at the bottom right. Okay, so now it says please complete items marked with this action, this icon, before continuing to the next step. Now the date and time is the first one. We have already pre-selected America's New York time zone. If you want to change the time zone depending on which time zone you are in, go ahead and click on it and change the time zone. Keyboard, it by default it selects English and US. Language support, again English, United States. Installation source, local media, which means that we are installing the operating system through the local ISO image. So it's already been selected. Perfect. Next stop, software selection. This is where it has by default the software selection as minimal install. If you leave that as is minimal install, then it will install the Linux operating system, but it will not have any GUI on it. Well, remember one thing, most of the time in corporate environment there are no GUI on Linux. But since we are going through some practice, we will go through some GUI practices as well, because I do want you to know how GUI works in Linux as well. So we'll go ahead and click on software selection, and that's where we will pick a couple of different additional software that are required. In the minimum install, we have other options as well. If you wanted to use system administration tools or any other tools, you could pick them. We could leave as default. Compute node, anything, any debugging tools, directory clients, hardware monitoring tools, development tools. Most of these tools are used by developers. Since we are not going through the development training, we will leave that as is. Infrastructure server. What type of server are we going to run on this machine? I will tell you, you could pick any one that you think you might need it later on. You could pick the DNS server for now, because we are going to cover DNS, which is bind, in this training. So you could pick DNS. If you do not pick DNS server at this time, there is no issue. We could always install DNS server or package later on. But anyway, just to show you how it works, I just selected one DNS name server. Anything else that you wanted to select here, you could. If you don't want to, just follow my lead. Then let's go to the next one, says file and print server. You could leave everything as is. As said, basic web server, we don't need it. Virtualization host, no. Server with GUI, yes, this is where we have to come in. And If you notice, as you are going down, all the other options that were available on the base environments are actually added here as well. So don't worry about it. They are repetitive. It's not that this option will have a different DNS server and with this base environment. So right now we are in the server with GUI environment. I want you to go down and pick KDE, which is KDE is a Plasma workspace, a highly configurable graphical user interface. I also want you to pick Java platform because if we are running certain application that requires Java, we could bring that up. Let's see what we have. We have all the virtualization tool. Um, okay, I think we are good here with the KDE. Now the next one is Genome Desktop. Now Genome Desktop are the desktop that also provide some type of applications for the user. Let's say if you wanted to use Firefox or if you wanted to use calculators or something on the GUI side, then you could select this desktop as well. So go ahead and click on Genome Applications. Any other tools we need? Internet application, email, chat, video conferencing software. We don't want that because most likely in corporate environment you will not be using any of these. KDE Plasma Workstation, Workspaces, Development and Creative Workstation, and that's pretty much it. You don't really need any other applications or add-ons for the selected environment. Now go ahead and click Done. Now you will see this option right here it will tell you checking software dependency. It means it is going to our ISO image and asking that ISO image, hey, this user has selected these many packages. Do you have these packages for me to install on this operating system? It's going to say, hey, okay, no problem. Let me go ahead and check that. So it's checking the source and it's checking the software dependency as well. So what is needed for those add-ons that we need to install. Installation destination, while it's running, we'll go to the next one. It says installation destination. Now, how do we want to partition our disk? Installation destination right now it says automatic partitioning selected. If you want to change that, meaning right now we have 10 gig, this is the disk size that we selected when we were creating the virtual machine. This size has shown up here is telling us we have 10 gig of disk space. How do you want to partition it? We are telling it automatically configure the partitioning. If you know or if your organization has a requirement to partition a disk into different slices or different partitioning, then you will go ahead and click on I will configure partitioning. Now go ahead and click on Done. Next one is kdump. Kdump is enabled if something goes wrong. K means kernel. If there is something wrong with your system, a kernel is going to write some messages, some logs that is often referred in Linux language as a dump. That is enabled. So it's always a good practice to leave that enabled. So this way, if you are troubleshooting with your vendor, let's say if you have CentOS, Red Hat involved, they could go ahead and take a look at your logs. Next one we have is networking and hostname. Okay, we are on a network and hostname configuration. At the bottom you'll see hostname. Go ahead and highlight what we have right now and hit delete and type in the host name of the Linux operating system. We'll type the same one as we picked for our VM, my first Linux VM, and click on apply. As soon as you click on apply, you'll see the current host name will change to the host name that you have picked. Now the second thing is to configure the Ethernet. Now remember, by default, if your machine or your virtual machine, this is your virtual machine, if it is running on a PC that has 1 gig of network port, it will show up here as speed 1 gig. And right now it is showing it's wired for me because I have selected, or my machine where I'm running this virtual machine is wired. So go ahead and click on configure, and by default it will show up the tab as Ethernet ENP0S3 is the name of our network adapter. So we'll click on general and we'll click automatically connect to this network when it is available. The rest of the setting is blacked out by default. You could leave as default. IPv4 setting is the setting for automatic DHCP. If you want to assign an IP, then you would have to change it to manual, but we want the IP to be assigned automatically, so we will leave it as is. And then the last one is IPv6 settings. We don't use that right now, so go ahead and click on save. So once you click on save, you will see it tells you automatically connected. It is given an IP already, and now you could go ahead and click on done. Okay, and so our network and host name has been configured. Now the last part is security profile. No profile is selected. You could leave that as is unless your organization has a specific procedure to put it in place for security policies. Then you could define it here. But for now, you could just leave as is and go ahead and click on begin installation. Once you click on begin installation, you will see at the bottom it will start creating your partitions that were selected, that you asked the system to select it for you. Now it's going to starting package installation process. While this is going through the package installation, we have two user settings to define. First is root password. So go ahead and click on root password is not set, and here you would have to put in the root password. Pick anything that you will remember. If you notice, I picked a weak password. You should pick a strong password if you are if you're working for a company or if you are in an organization. But if you are just following my lab or you're doing this everything as a tutorial, that is fine. You could pick a weak password. However, if you notice at the bottom it says the password you have provided is weak. The password fails the directory check. It is based on a dictionary word, which you will have to press done twice to confirm. So okay, I understand it is a weak password. In order for me to keep that password, I have to press done twice. 1, 2. Now it has taken that weak password. User creation. Let's go ahead and create our first user. Full name. Let's put in our first name. By default, Linux takes the first name as the first letter, first initial. Last name is a complete last name. So for me, the username will be IMf&x. Keep your username shorter than 32 characters and you do not use spaces. That is fine. We are not using any spaces. We are only using 6 letters. Make this user administrator. You could leave that out. Requires a password to use this account. Yes. Let's pick a password. Again, it is weak, I understand, and I would have to do the same thing done twice. Okay, it is done. Now, if you come down and you notice right here, the operating system is installing, or this wizard is installing packages for this operating system. Total number of packages that are required to be installed are 1397. You might have a little more or a little less, but that's okay. It depends and it changes over time what other packages are installed, what other dependencies are installed. So again, if your packages do not match with my packages, do not panic. You are okay. So now you'll see it is going through the packages installation. At this point, it has installed almost 400 packages, and there's still about 600 to 800 packages that needs to be installed. And this process will take, I would say, somewhere between 10 minutes to 30 minutes. I am going to fast forward this entire process to save time. Now the package's installation has been completed. Now it is going through some post-installation setup. Alright, finally our installation has been completed successfully. Now CentOS is now successfully installed and ready for you to use. Go ahead and reboot to start using it. Click on reboot. Once the system comes back online, it will give you the initial setup page. The first page is about licensing. You have to accept the license. Click accept license agreement and click on done. Network and host name. If you notice, we have already selected this network and host name configuration during our installation, so that you don't need to do it again. Click done. And right here it says finish configuration. Go ahead and click on finish configuration. Alright, finally our entire Linux installation has completed. Now we have to log in the first time. Click on your name, or you could also log in as root. If you remember, you have picked a root password, you would have to click on not listed and type in username root and password, but for now we'll go in as ourselves. And we will put in our password. Click on sign in or hit enter. Alright, this is the desktop. This is how it looks like in CentOS. It is very similar to Red Hat CentOS. You have these icons right here. You could resize them if you want to. You could delete any icon. You could create an icon. And you could explore other things on the application and spaces. So also one more thing, when it starts up, it also gives you this welcome page. So you just leave as English. Go ahead and click on next. Typing, if you want to change anything, you could leave it default. Location services, I usually keep it off. If you want to leave it on, it's really up to you. Click next. Connect to online accounts, you don't have to do that. Click skip, and then start using CentOS Linux. So once again, congratulations. So now you know how to do the complete Linux CentOS installation. If you think that you missed something, then I would recommend you to go ahead and delete this entire Linux VM and go ahead and create a new virtual machine and do the Linux installation again from scratch. The more you do, the more practice you will do, the more you will learn. Alright, good luck. Creating virtual machine. In this lesson, we will create our first virtual machine, and on which we will be installing our CentOS Linux operating system. Well, virtual machine is basically nothing but a shell, a container which holds the information of a machine, CPU, memory, disk, and all the resources. This virtual machine is going to be sharing the resources wherever it is installed. So let's say if it is installed on my laptop, it will be sharing the resources from my laptop. The Oracle Virtual Box. I'm going to open it up. Okay, so this is the window for the Oracle VirtualBox. I'm gonna click on New. The name I will pick is My First Linux VM. And if you notice, the VirtualBox is smart enough to pick the operating system type and version for you. You probably notice that you probably not gonna see the 64-bit. You are probably seeing 32-bit. Now, if you are seeing a 32-bit, then either your computer is a 32-bit architecture, or the virtualization technology is not enabled. First, let's find out if my computer is 64 or not. So let's go to Start menu, computer, and I'm gonna right click and go to properties. Once the property comes up, you will see here, it will tell you if it's Windows 7 PC. And right here, you're going to see where it says system type, it says 64-bit operating system. So that's one way, that's one of the reason that when I'm building my virtual machine, it is coming up 64-bit operating system. The second reason you might not going to see 64 is if you don't have virtual technology enabled in your BIOS setting. If that's the case, I have actually pasted an article in in this lesson, and there is a link to it. I would recommend that you could go to that link and try the settings that are recommended and see if it changes to 64 setting. I'm sure it will work. If not, you could always email me back. So I'm gonna leave these settings here. I'm gonna click next. Now here it's going to ask me the size of the memory I want to assign to this virtual machine. Now by default it's picking up 1 gig of memory. Now you should also keep in mind how much memory do you have actually in your laptop. So in my laptop I have, let's look at my computer again, right click, properties, and you will see here my computer has installed memory is 4 gig. So it is wise that I keep the memory below that digit, that number. So I have 4 gig, so I'm gonna give 1 gig of that memory to this virtual machine. And click next. Create a new virtual disk. Yes, it will create a brand new virtual disk. Next, leave the default. Dynamically allocated, leave the default. Click close. Then this is the size of the disk. By default it picks 8 gig. I want to pick 10 gig just to be safe, so I'm gonna just click inside of this box, remove, and type 10 and click create, and there you go. This is my first virtual machine that is created. Again, think of it as a piece of hardware that's been created for me. I'm on the assembly line. I'm putting the CPU, I'm putting the memory, I'm putting the hard disk, I'm putting everything in that machine, and I build that machine. So once the machine is built, what is the next step? Next step is to install the operating system. And in our course, we will be working with CentOS operating system. So I'm going to power this on and I'm going to install the operating system. But of course, before I go ahead and install the operating system, I do need the software ISO image. So in the next lecture, we will cover how we're going to download the ISO software, and then how we could attach that software to this Linux VM, and then we will boot off of that software. We have learned what is Etsy password, shadow, group, login defaults, and how the configuration or parameters in each of those files work. Now in this lecture we are going to create a user account and change its password. So that user account can be used in the later lectures to set the password parameters for that specific user, and we could play around with that specific user. So what we'll learn in this lecture are 2 basic commands, and I'm sure those commands most of you are already knew about it. One is user add and second one is password. User add is to create the user, and second one is to set or change that user's password. There are other user related commands that can also be used, such as user delete if you want to delete the user account that's been created, group add If you are creating a new group and eventually all the users you wanted to create want to be assigned to that user, you could use group add or group delete if you want to delete that user that is no longer in use. And the last one is user mod, which is to modify the user. All those 4 commands, I will really go quickly over them, but I'm sure you already know them. But our main commands that we wanted to cover is user add and password. Again, this lecture is not about showing you how user add or password command works. This lecture is about creating the user and changing his password, and then eventually using that account to run a certain different commands for security purposes. Let's go into a Linux machine. Okay, I am logged in as myself. My host name is my first Linux machine, so these are the 2 commands you should always run whenever you log into your Linux machine to make sure you are not executing the commands on a wrong machine. To create a user account, you'll run user add and the name of that user. In this case, I'm going to create a user Babu but. It returns my prompt back, which means it created my user account. I could run ID Babu but, and you will see that user ID that is assigned to Babu but and group ID are assigned to Babu but is 1006. By the way, just Babu but is just a character in one of my favorite shows, Seinfeld. So most of the characters that I pick are based on that TV show. So no other specific reason. So just the character that I'm picking. All right. So now when you do grep Babu but in etc password, you will see its username, the password column X, ID, user, home directory, and the shell it's using. Remember we covered that in etc password lecture earlier, few lectures before. Second lecture we covered about Babu but in etc group, and it tells you the group name is Babu but, its group password, and 1006 is the group ID. Then we covered about etc shadow, exactly. And that's where it's telling me that Babu but is the username, and here you see 2 exclamation point, meaning it's telling me that I have not yet set a password for that account. The password age, when was the last time password was changed? Since, if you remember, what was that? I believe it was July 1st, 1970. Since that day, if you calculate until today, you will see the total number of days counted are 18,085. And the remaining fields you are already aware of. This is the number in which you cannot change the passwords between. This is the number in which the password will expire. This is the number, I believe, where you have password warning. Yes, I just remember. So always keep a reference, a cheat sheet with you to remember those. So now the next command that we will learn is password to reset the password of Babu but. It's going to ask to change the new password. Put in a new password again, and all authentication tokens are now updated. When it says bad password, the password fails the dictionary check. It is based on a dictionary. Is because I have picked a password that is actually found in a dictionary, but that's okay since you are already root can do anything. But if you were changing this as a regular user, it won't let you make that change. Okay, now when you do again grep Babu button at C shadow file, now you will see the actual password. It is really long, which is encrypted password. So that is completed. Now the next thing is that I wanted to really quickly cover is the user delete. It's the command delete a user account and related files. So if you wanted to run that command followed by the user, let's say in this case Babu but, it will delete that account. Same way, if you wanted to create a new group, you could do group add, and it will create a new group. Group delete will delete that group, and the last one is user mod to modify the user. Now remember, this modification is not the modification of CHH. CHH specifically deals with changing passwords, setting the password limitation, the maximum number of passwords, the days and stuff. This user mode is to modify user IDs, and let's go in and I'll show you the expiration date of that user, not the expiration date of the password, meaning after certain days the account itself will be locked out or expire. It will become inactive if you use -F option. You could change its group ID by typing -G. It will change the new login. It will change the lock. If you wanted to create a user account for only 10 days, let's say there is a consultant in your company who is there for only a month or 10 days, you wanted to create his or her account, and after creating the account and the person leaves, you wanted to lock that account. And so the best way to do it is picking -L option. You create an account with minus and user mod L option, and after certain days it will lock it out and you're good, so you don't have to worry about that account going in and deleting it. Well, it's good practices that you should go in and delete or disable it, but just make sure you have that -L option set. Then the password, if you wanted to change the password using user mod, you could do it here as well with -P option. Why do we have that as separate to password? I'm not sure why, but anyway, it is there. There are two different ways you could do that. That's fine. And if you wanted to change its shell, you wanted to change its user ID, you wanted to unlock it, and you wanted to put it in SC Linux for any more configuration and the files that are related to that command. So anyway, so remember that user mod command is only dealing with user modification, meaning user ID, user login, user disabling. Change command is the one that deals with password security parameters. Of course, that was something that we'll cover in the next lectures. Okay, now we actually going to run the ch command. So it's not change, again it's ch. So change age. That command is specifically used to set the parameters around the password. It is not used to make any changes to the user account itself. To change or make any changes to the user account, you will use user mod, which we learned in the previous lecture. Okay, the command is, again as I said before, is per user basis. You could actually run the command ch with -d, -m, and all different options that we covered. Again, -d is for last password, -m for minimum, uppercase M is for maximum, -w is for warning, -i is for inactive, -e for to expire. Okay, now let's get into my Linux machine right away without wasting any more time, and now we're going to make the changes of the user we previously created in our earlier lecture, and the username was Babu Butt. Okay, so we know the account exists. We have created, we verified it. Now we are going to make the change of that Babu Butt password parameters. Before we make the change, let's grep for Babu an etc shadow file. Since I only have one Babu, so I could just simply grep for Babu instead of the complete name Babu Butt. Okay, here you'll notice it has all the default information: the username, the password, the last password change, minimum, and all other parameters. Same default value. These are the value from here till the end are the value we are going to change. And again, the reason we are making this change is so we could secure our environment. And of course, our entire topic is about securing the environment. So we make that change for one specific user to change the environment. Now, to run the command chage, you could do -d for last day, and I would not like to make that change because I want it to be consistent with the system's time, and the system time is days since January 1st, 1970 that the password was last changed. If I make that change right now, I won't have I can't keep track of the password change. So right now, if I take this number and minus the date of January 1st, 1970, then I could tell the password was changed today. So I don't want to make that change. I want to keep that for my own information. So I will start with -m, which says minimum. What is that minimum? The minimum number of days required between password changes, that is the number of days left before the user is allowed to change his or her password. Meaning if you are changing password today, and if I make this 5 right now, it means you cannot change the password until those 5 days has already been passed. So right now, as you notice, it is set to 0, meaning there is no restriction, but for this exercise we'll put 5. Next one, we have uppercase M, which is maximum. What does this maximum mean? It means the maximum number of days a password is valid. After that, user is forced to change his or her password. So right now, the total number of days I have to change my password is 99999, which is a lot, too many days. So the system is not going to prompt the user to change his or her password until that day comes. And of course, hopefully we all live to that age, but that's not possible. So it's good to make the user change his or her password every, let's say, 3 months. So that makes it 90 days. So I will put 90. So every 90 days, the system will prompt this user, hey, your password is expiring, so please go ahead and change the password. Then the number 6 is warning. So for warning, meaning before it expires, so I want the system to notify the user 10 days before the password expires, which is 90. So I'm going to put 10. So automatically the system does the calculation for you, and it will see, hey, the maximum number of days is 90, so I have to remind the person 10 days before. Next one is -e, is to inactive. That means the number of days after password expires, the account is disabled. So if your password expires today, your account will be disabled tomorrow, day after tomorrow, or whenever that is specified right here. So I will say delete, disable the account if the password is not changed. Disable it after 3 days. Okay, the last one is expire, which I pick E. Sorry, the inactive one was I, and the last one expired days. Since this account is disabled, that is an absolute date specifying when the login may no longer be used. So you could specify a number when the password is actually completely expires. Actually, the earlier one, the inactive one, is an inactive, meaning it's making the account is inactive. Now the expire one, days since January 1st, 1970, that account is disabled. So it will does the calculation until that account is disabled. So for now, you could leave that. Okay, so I just ran the command and it gave me an error message. Okay, now I know why it gave me an error message, is because I forgot to specify the username. Which user am I picking to make that change to? That is why I'm getting this options. So that is Babu Butt. Okay, so it took it and it gave me the prompt back. Now I am going to view these parameters in etc shadow file. So I'll do grep Babu Butt etc shadow, and here you'll see I didn't pick the -d option, which is to last day of the last display. You can make your own last day from whichever date if you want, but I'm just leaving it to system default. That's why I didn't pick D. The next one, if you notice, I have number 5, which was the minimum day I picked right here. Then the next one is maximum. It has system will remind the user to change the password or force the user to change the password after 90 days. And then the next one is W, is a warning. It will remind it 10 days before. And 7 is that it will will inactivate the user account after 3 days of password expiring. So that's how the CHH password works. Parameters to change it. If you want to make that change throughout your systems, then which file do you have to modify? Yes, etc login defaults. And that's a common practice. I would recommend you can modify there. But if you are making changes to a few users only, then I would recommend that you use CHH command. So that's one of the CHH command that is mostly used for securing your user environment. Let's look at this next lecture, which is about locking or disabling user account manually. So in the previous lecture, we covered that by default, the user accounts will be locked or disabled after a certain number of days of inactivity. But what if you wanted to, or if you don't have that mechanism in place and you just want to check the list of users who haven't been logged in for a certain number of days and you wanted to manually lock them? Let's cover that part in this lecture. So another command to check user status is a last log. That command followed by -b option and the number of days, which directly lists users who have not logged in the past 90 days. However, it also has a header, so use tail to skip the header now. So to remove the output, you mean remove the first line of that is the header, you could use the tail -n+2. By the way, I will run these commands, all of them one by one, but let's go over all the details or all the contents of the slide. Then you could also use grep to filter out system users to be specific. So there are system users that you're going to see that don't have a login, or they don't log in actually. So you could exclude them to be specific to those users that are not system related. And that's the command to disable your user. So once you identified which users that you have or which user been pulled up, then you could disable them by running the command user mod space -L, or uppercase L, remember that is username. You could also use the command password with lowercase l and username. Or the third option is that you could change the user shell to bin no login in the etc password. This is a bit, I would say, a little risky, so don't modify the etc password, and you could make a mistake. So the best way to do is use user mod or password command. And now you have disabled it. What if you have disabled a user account by mistake, or you wanted to enable a user account after finding out, hey, this user should not have been disabled, or whatever the reason you wanted to re-enable it. To re-enable it, use the same command, but instead use uppercase. For password, use lowercase. And for change the shells, you could just modify the shell back to bin bash. Okay, so now let's go into our Linux machine, and here we'll run a few of those commands. So let's say I need to find out the list of users that haven't been logged in the last 90 days. So first let's do man on last log, and you will see it tells you report the most recent logins of all users or of a given user. B is before days. Print only last log records older than 90 days. So I'm using B option, meaning give me all the users before the 90 days. So let's run that. Last log -B and 90. This is going to give me a whole bunch of list. That is also, but before we get into refining that, the one I listed to remove the header, you notice that there's a header here. It says username, port, from, and latest. So I'm going to get rid of that header, that first line. And for that, I will do pipe tail -n plus 2. This will get rid of that first line. If you go up, you probably notice, see, there is no line. Okay, and the last part I said to exclude all those that says never logged in. Exclude all of them. So for that, you will filter out one more time, and you would do grep minus v, and then you could put no or never log. So colon, single colon, never log. That should be enough, and you hit enter. And what happened here? Grep minus v, never. Oh, I used uppercase L. That's what happened. And there you go. That's what the information we needed. And as you notice, I have these number of users, total 4, Seinfeld, Lane, George, Kramer, that actually have never logged in for the last 90 days. Now, I have identified that. You could also narrow down your search by picking only the first column is awk print $1, and this will only list the first column, which is Seinfeld, Elaine, Jordan, Kramer. Now again, you have identified those users. Now the time to lock them, and to lock those users, you could run the command user mod minus L username. So in this case, I will do Seinfeld, and it has locked the account. How do you verify it has locked? You could actually grep Seinfeld from Etsy shadow file, and you will see this little exclamation right here, which tells that the user cannot log in. So if I try to log in, duplicate session, and I try to log in Seinfeld, put in a password, and it would tell me access denied. There you go. See, that's what happens. So if you want to unlock, all you have to do is U to unlock or re-enable that account. So now let's try to put in my password. There you go. So the password came in and it works. There was one failed login attempt since the last successful login. That was a fail, and that's what it complained about. Same thing you could do. Let's minimize or move that to the side. Same thing you could do with password, passwd minus L option, and it will do the same thing as user mod. Why we have one command or not the other, or why we are not using one or the other, it really doesn't matter. As long as you get your job done, get your security done, everything is under control, that's what matters. So now you know how you could lock or disable accounts manually in your Linux system, and that is one of the critical part that you should know to secure your Linux environment. Now let's look at another security measure, and that is lock user account after 3 failed attempts. So when a user tried to log in and the user provided a password, and the 3 times they provided the password and it's been incorrect, the account will be locked out. And how can we implement that security measure in our Linux environment? So let's look at that. First we have to do is become root and copy these 2 following files, because any mistake that you do in these 2 files, it will prevent you from logging into the system, regardless if you're logging into as root or as any user. So make sure you copy these 2 files into a different directory. I chose temp. You could choose any directory that you like, or I would also say please take a snapshot of your Linux VM. The next thing we have to do, edit these files. Of course, once these are backed up, copied, we will modify both of them. And what we will modify it with. In the first line, when we open up the system auth file, we will add these parameters, which is auth required pam underscore tally2.so, deny equal 3, one error equal fail. If something goes wrong, what the error messages will throw, it will throw fail. And unlock time is 600, meaning 6 minutes, meaning if the system locks the user after 3 failed attempts, then the system will automatically unlock it after 6 minutes. Then you have to go down, scroll down to the account section and add the second line at the bottom of that section. And that line is account required pam underscore tally2.so. Try to log in as any other user and then enter the wrong password 3 times. This is what we will try to do in our exercise. And then you could see how many failed attempts a user had by issuing this command, pam underscore tally2 dash dash 0 equal the username. And we will find out if the user cannot log in. We will verify that the reason the user couldn't log in is because it failed that many times. Also, user will be automatically unlocked when using the lock time, which I already explained. It's just 6 minutes. If you want to enforce this or unlock a permanently locked user, use the -r option together with the -u option. And that syntax is pam underscore tally2 -r -u and username. I have tested this entire process already, and I have tested in CentOS and Red Hat. It might be similar in Ubuntu or Debian or other Linux distributions, but please take cautions. Try it out first and see if it works in other distributions as well. But what I'm trying to say is I have not tested that in any other distribution except CentOS and Red Hat. So now let me log into my machine and we'll go over one by one and see how we could test locking out a user after 3 failed attempts. So I have my Linux machine right here. And the first step, as I said, is we will make a copy of pam.d password auth into temp. We will do the same thing for system auth temp. Alright, now it's copied. Perfect. Now we'll go in and modify that. Now before modify, I already copied these parameters into a file. I'm just going to copy and paste it there. So that parameters I have copied in my temp parameter file. And these are the 2 parameters. Now I will go ahead and vi the etc pam.d system auth file. Vi it, and on the first line we have to paste the first line, not the second line. It's just that I copied it. That's why I'm going to remove that. Now make sure you're just aligned with the format. It will still work if it's not aligned, but it will look neat if you have it aligned right. Then the second one, next scroll down to the account section right here, as I said, section, and add the second line at the bottom of that section. So the account section is right here. And I'm going to add that right here. Now again, I copied both lines, so that's why I'm going to remove this line, the first one, and leave the account line only. And again, I'm going to format it the way it should be to make it consistent with the file. That's it. You just go ahead and save it. And you notice that you have updated system-auth. Now many times when you update system-auth, it also updates password-auth. So let's verify if the password-auth is also updated. So vi the etc pam.d /password-auth. And you notice, nope, it's not updated. That's fine. We'll do it here as well. The same way we did it before. Come down to the account section. Required. Okay. Now please, once again, pay close attention. The auth section goes here, and the account section goes here. Please do not add to both lines by mistake. I just copy paste. That's why it was showing up 2 lines. So take extra precautions when you make changes to the file. So that is changed. Let's save it. Now both files have updated. So let's try to see if that policy has been enforced. So I'm going to try to log in as a user that I have already in the system, and that username is Seinfeld. And I'm going to put in a wrong password. 1 time, 2 time, 3 time, and now at this time it should have locked me out. Now I'm going to put in the right password for that account. And it is still giving me access denied. The reason because I cannot log in because it has already locked me out. So let's verify it by running the command pam underscore tally 2 dash dash user equal username, which is Seinfeld, to verify if my account has any information there. And it does says that there are 4 failures, of course, at the time of the failure, the date, and where is it logging it from. So it is locked out. Now, if I wanted to unlock that account right away, I would have to do pam underscore tally 2 minus r minus u, and this username Seinfeld. Now it has logged out, unlocked it. So if you run it again, the earlier command pam underscore tally 2, you will see the failure has reset to 0. So now let's come down to that putty session again. I have it on this side, and I'm going to put in the password, and you will see it says the account was locked due to the 4 failed login. So it's telling me why it happened before. So now we logged in, and it's telling me there were 4 failed login attempts since the last successful login. So that's how you could actually lock a user if the user tries to log in with wrong password 3 times. And that's a very good security measures. Every Linux operating system should have that, and every system administrator should implement this security measure in their Linux environment. Centralized authentication service or directory services. Since we are talking about user account management, this whole section is about how we could secure user environment on your Linux machine, and those user environment mostly is local to your system, meaning locally created on your system. So as a best practice or a best security practice as well, that you should also use a centralized service, also called a directory service. A directory server is somewhere where all the users are sitting, and those users could log into multiple Linux machines. So you do not have to create each and every user multiple times for multiple servers. So if you have 10 servers and you have to create one user in every server, you would have to create 10 accounts for every user. Or you could use a directory service in which you could just create an account on one server, and then you could have that server authenticate against all those Linux machines that you want to log into. And in other words, you could also say, just like in Microsoft, they have an Active Directory service where you could use or create your account and log into all other Windows environment. Let's look at the definition of directory service. A directory service or server provides a central repository for storing and managing information. Almost any kind of information can be stored, from identity profiles and access privileges, which is the focus here, and I already told you is accessing the system or creating user accounts. Anyway, going again from identity profiles and access privileges to information about applications and network resources like printers, network devices, and manufacturer part or many other objects. Information stored in directory server can be used for authentication and authorization of users to enable secure access to enterprise and internet service and application. This is pretty much what I explained it earlier. Anything that is stored in the Active Directory, aside from the user account, could also be like printers or servers or users and many other objects. Anything that you save in the directory service is called object. It is also referred to as single sign-on service or server too. Single sign-on mean, as it says, as it reads, one server and one user on that server becomes as a single sign-on source to log into every server that it's trying to log into. Examples of directory services are Open LDAP, which is mostly used for Linux environment and nowadays is very commonly used and very popular, and it's open source and free to use in our Linux environment, where you can manage all the user accounts and have that integrate with the PAM mechanism or PAM modules as well. Red Hat Identity Management. That is also something new that was introduced a few years ago by Red Hat. That is an identity management service by Red Hat that you could use to integrate with your Linux operating system to have as a single sign-on source. Then WinBind is another one, or Microsoft Active Directory. Now you're probably thinking, how come Microsoft Active Directory can work with Linux? Well, there are plugins, there are clients that you could install on your Linux machine, which will let you authenticate Microsoft Active Directory accounts to your Linux machines. It's not that hard, it's very easy. You could actually use a WinBind um, client as well to have that as a middleware to have the authentication coming in from Active Directory to your Linux machine. Anyway, the whole point of this lecture um, is to bring up the directory service topic. So if you have accounts that are being managed locally to your system and you are putting security around those accounts, it's best that you put the security on the directory service side so you don't have to deal with multiple Linux servers, especially if you have thousands of Linux machines. The next lecture is about disabling SSH access for a specific user. We already learned how we could restrict access or disable access of a root account to SSH into a machine. But what if you wanted to disable access for any specific user, not just all the users, any specific users? So that can be done in a very easier way, using the same file that we used to disable access for root. So what we have to do here is, of course, we become root, and as a good practice, as I always recommend, and that you create a backup. So make a copy of etc ssh sshd underscore config file, put it somewhere in /temp, or where you could retrieve it if there is something goes wrong in the original file. Then you edit the file, edit the following line in sshd underscore config file, but if that line does not exist, then simply add that line at the end of the file. So the line is simply deny users space the username. Of course, in this case, the username is not exact the same username as I've written. It will be the actual username that you want to restrict or disable the SSH access to the system. And then, of course, at the end, to have that in effect right away, you have to restart the SSHD service on your Linux machine. Alright, so now let's try it and see how we could get it to work. I will log into my Linux machine and I will try that out for one of the user in our Linux environment. So before we do that, let's go ahead and copy etc ssh underscore ssh d underscore config. I wanted to copy it to our temp directory. I already have an older copy of it. I will go ahead and overwrite it. So hit yes. Now the copy is made. Now edit the file vi etc sshd underscore config and look for the line that says deny. Hit enter, and you could look for a line by simply typing slash and the name that you're looking for, the keyword. Hit enter and you will see it says pattern not found. It means there aren't any parameters in this file yet that indicates that or that dictates that this user should not have SSH access. So what I'll do is I'll go at the end of the file, which you could just scroll down or simply hit Shift G, and it will bring you down all the way down to the last line of the file. And whenever I add any new parameters to any configuration file, I put down a comment what that parameter is for. So I'll say deny any specific users, and that parameter would be uppercase D, deny, uppercase U for users, all one word, space, and the name of the user. In this case, I am going to pick a user that already exists in my system, and that is Seinfeld, Seinfeld, and hit enter, or just leave it as is, and just simply save the file. Again, make sure that user exists, because if it does not, it's really not going to apply any of those changes to that specific user, because it's not going to find that user. Alright, so before I go ahead and restart my service, I will make sure as a Seinfeld user I'm able to access the system, just to first make sure. Seinfeld, password in, and I am in. Perfect. So now I'm able to access. I'll go ahead and exit out, and I will now restart the system SSH service. Okay, it's restarted. Now I'm going to log in as Seinfeld again by clicking on duplicate session. Seinfeld, and I can now log in and it will tell me access denied. That's how you could restrict a specific user's SSH access to your Linux machine. That same function or that same requirement can be achieved by modifying the etc password file, and instead of putting /bin/bash as its shell, you could just put in /bin/log no login as its shell, so it won't be able to log in either. And of course, there are many other ways. You could disable its password, you could lock that user account, or you could go to pam.d configuration files to also disable that specific user. Let's look at locking or disabling user accounts. Disabling inactive accounts ensures that accounts which may not have been responsibly removed are not available to attackers who may have compromised the credentials. So it is important that system at least should automatically lock those accounts that haven't been used for a while. So a file that is etc/etc default user add file, which is the default file whenever you run a command user add to create a user, it actually goes into this etc default user add file and looks for the default value in place, and that is used to set the default configuration of a user whenever user add command is ran. To specify the number of days after a password expires, which of course signifies the inactivity, until an account is permanently disabled or locked, add or correct the following lines in etc default user add. And of course, when you look at the etc default user add, and you will see inactive line or row or section, that line you have to replace the numbers with the correct number of days that will reflect your policy or your security setting. So we'll look at the etc default user add in a second. Then we have a value of 35 is recommended. So if you wanted to put a value in there in inactive section, then 35 is recommended. If a password is currently on the verge of expiration, then 35 days remain until the account is automatically disabled. So let's say if your account is expiring or your password expired today, you still have 35 days until your account is completely locked out. However, if the password will not expire for another 60 days, let's say, then 60 days plus those 35 days, that becomes 95 days. That are the days until the account would be automatically disabled. So let's look at our Linux machine and we'll cover the etc default user add file. So I am logged in as root and I'm logged into the correct host. Good. So now let's do cat etc default user add. And if you notice, it has a few lines or few parameters that you could set for your every time you run the user add command, and the one that we are talking about is this one, inactive, and that has to set to equal to 35. Other ones, other fields, let's talk about them one by one. So in etc default user add, the group is the first one, the second one is home directory, third is inactive, expire, shell, skel, and create mail spool. These are all the fields that are in etc default user add configuration file. So now let's go back and look at that configuration file one more time. And then we could say group. The first one is the group. So which means maximum number of groups for which a user can be member of. If you have a user, let's say um, Peter Pan or ABC or whatever the users that you have, that user cannot be a part of a group or part of groups total of 100 or more than 100. So if that user is part of a group of 101 groups, then it's not going to work. Then when you create the user add, when you create a user with user add command, the default home directory will be /home. Here is inactive. This is the value that we're talking about, or this is the parameters that we're talking about. Number one means never inactive. That is always active. So by default, the operating system has this configuration. It says never disable or lock the account. Expiry is the date on which the account should expire. It is given in the form of year, month, and date. Now we're talking about the account expiration. We're not talking about the password expiration, which we talked earlier in etc login.defaults. Remember? That is different. That was for password, and this is for the account. So there is no value set because we don't want the accounts to expire. So that's why we leave it as is. The shell by default is bin bash. Skel is the directory from where the default user profiles will be copied to the user's home directory. So if you have that set and you have certain parameters that you wanted to set or certain environment that you want to bring in, then you have to specify in that directory. The last one is create mail spool equals yes, meaning this option ensures that a user will have a directory of its username in the var main where the mail process can store mail messages. So if a user is doing some activity or someone sending a mail to that user, that mail will go into the var and the username and the mail directory. So these are the parameters that you could actually set. And these are something new that's been added. But if you run the whole user add -g to specify the group -u and whole different options, you could do that as well. But those options have already been set for you. And again, the one that we're looking at is the most important one is inactive. Best and one of the main security measures is that if a account has been inactive, nobody has logged in for a while, that specific number of days, lock that account, which is a very good practice that everyone should follow. And the way that you could find if the account is locked or not, you could grep for that user. Let's say IFSol etc shadow. You have to look into etc shadow and you will see the username colon, and right before $sign you'll see an exclamation character. That means the account's been locked. So these are the default values. Keep that in mind. Try them. And of course, every time you try anything new that you never tried before, always take a snapshot of your virtual machine or take a backup if it's a physical machine. Implementing user ID, group ID policy in your environment. User ID is a digital number that is assigned to a user account or a service account or a group or a service group account whenever that user account is created. One of the security practice in Linux is to separate the user ID and group ID from application accounts or system accounts. So this way, if you are creating accounts, let's say for James, John, Michael, or whoever that you're creating, the the good practice is that you keep their user ID completely separate from this application accounts that you will create. And application accounts are like Oracle, SAP, or Apache, or any of this application that you have installed that requires a user account to be created in order to work together with that service. Usually the system's accounts, user ID and group ID range from 0 to 99. So if you look at your etc password file, you will notice all the service accounts are all starts from 0 all the way to 99. And of course, a 0 is always assigned to root account. User accounts always starts above 100 plus. So by default, your operating system knows every time you create a regular user account, it will assign a user ID starting with 100, 101, 102, and so on. The user ID and group IDs are assigned by default when running user add command. So if you're running user add command followed by the username, what this user add command would do is it'll go into the etc password file and I will look into which user account was the last one that was added with the user ID. It will take that user ID and it will increment to a new number. So the best practice is to create the first user when you have the operating system installed. So you create the first user with manual ID assignment. So the operating system will assign the user ID by incrementing the last user ID assigned. Meaning, if you want if you want to add a user, the first user in your system, the good practice is, for security purpose, is to pick a number that is higher or different from our regular conventional numbers. And those conventional numbers are 100, 101, 102. So it's not easier for a hacker to hack or go after a user ID by looking at, hey, I know the user ID for this user is usually this, or the system's ID is that. So user add minus u is to assign the user ID, and 10,000 is the number that I usually pick, and that's the standard that I have seen in the corporate industry that usually the corporate security team follows. And then you put a username. This way, every time you create a new username, you will get the 10,001, 10,002, and so on. The security documentation also in your corporate world should also include the policy of separating user ID for different groups as well. So if you have different groups accounts in your Linux machine, let's say you have user accounts for QA department, DevOps, systems, BI. So the good practice is that you dedicate sum of the range for those particular groups. So let's say the 10,000 would start for systems, 20,000 will start for DevOps, 30,000 will start for QA. Now keep that in mind when you creating users for those different groups in your environment, in your company. The last username will be picked by your user add. So regardless, let's say if you are adding a user for systems and you want to assign the IP of in the range of 10,000, but the user ID will see the last user ID that was assigned in etc password was 30,000. Then it will pick 30,001. So it's best that you create a user with a manual option with -u 10,000. So that's a very good practice to secure your environment. So when you are going for a job, a lot of times people do ask you, how do you secure your environment in Linux? So by implementing a user ID and group ID policies to dedicate the user ID is one of the best ways to secure your system. Now let's look at my Linux machine. I'll go over some of the commands to see how we could implement that policy. So right now, if you look at cat etc password file, you notice the last um, account I have is babu but, and that user ID is assigned 1006. If I go ahead and create another user add, let's say Susan, hit enter, and now when I do cat etc password, you will see it has given 10,007 ID because the user add will check the last user ID that's been used and it will pick the next one. So what you should do is you should pick a manual number. So user add -u, let's say 10,000. And now you create an account for another user, let's say David, and hit enter. Then you do the cat etc password, you'll notice it's assigned 10,000. Now the next time you run the command user add for a new user, let's say Banya, and hit enter. And now you do cat etc password, you'll see it has given an ID of 10,001. So that's why it is important that you keep user IDs separate based on the user accounts, based on the service accounts, and based on the different groups that you have in your company. So again, the groups are QA, DevOps, system, or whatever. And that's a very nice and cleaner way and easier way to manage your user environment and of course keep your environment secure. Now, as we getting into the security, here's a very important file that you really need to know that will set the security parameters for user account passwords, and that file is etclogin.default. So we know that the command is change age command is used per user, and to use that command, which by the way I will show you in the later lecture how we could use that command to specify those number of minimum days, maximum days, last day inactive, expiry date, and warning. And as you notice at the end it says user, so you make that change to per user basis. Now what if you want to set those default values for every user that is created in your system? What I means is, what if you have to create 10 users? Would you run chh command for every user to set the maximum days that is allowed to have the change password one by one? Or would you rather have that value set in some kind of default configuration where every time a user is created, that value is automatically set for that user? For that, there is a file, again, it's called etclogin.default. In that file, you'll see there is a pass underscore max underscore days value, minimum days, minimum length, warning age. All those settings can be set up as a parameters in that file. So let's look at that file really quick. And here I have my Linux machine open. I am logged in as root, and I will go ahead and do more on etc login.default file. By the way, it's def defaults, not def. That's just a mistake on my slide, so please make that note. When you hit enter, you will see right here everything that is set as a hash sign means it's just a comment. This is the password agent control. Let's go down one page, and this is what I'm talking about. If you make the change here and specify the default settings that is based on your corporate or your company requirement, you could set that up, and the next time you create a user account, will have that setting applied to every user account. Also, there are other values that could set in this file as well. So every time you create a user, minimum max value for automatic UID selection user add, whenever you run that user add command, the value or the UID is assigned by default to that user. It starts with 1000. So if you wanted to make that more secure, sometimes I have seen in corporate environment they start the user ID with 10,000 or 20,000 or a number that cannot be guessed easily. You could put that in. UID max meaning from 1000 to 60,000. You could have total of 59,000 users, or you cannot assign anything that any ID to a user which is like, let's say 60,001. Sys user ID minimum, system user ID max. This is the user ID for the system's processes, anything that is set up as a system process user. There are other ones as group user, group max, the same way that for the users. Create home directory. Yes, every time you run user add command, it will create an ID and group. An encryption method that is set by default. Remember in the last slide I went over there are 5 different settings, and the setting that is used to create the user encryption of that user password is SHA 512. Now you're probably wondering what is those SHA 512 and different encryption. Trust me, that gets very complicated, and I don't want to get into that right now. If you really wanted to learn more about those encryption, I would recommend you to go ahead and search online, and I'm sure you'll find tons of information on that. UMask is when you create a user. Every time that user creates a file, that file gets created with the specific permissions, and those permissions are actually assigned right here, and that UMask permissions will be given to every user that is created. Anyway, this file, guys, remember this file is very important at clogin.defaults. That file is actually controls how the passwords age minimum maximum is set for each user, and it is very, very important for you to know this file when someone is in the corporate environment and wants to tighten up the security. That person always have to start with a user level. That is why in my lectures the first section that I'm going through the security part is at the user level. And when you talk about creating users, this file is the one you really need to remember. Now in the coming lecture I'll show you how to use the chh command that could used to set the user password minimum days and age. Hello everyone, this is your instructor Imran Afzal, and today I am going to talk about how we could secure user environment. When we talk about securing user environment, the first thing that comes to mind are the files or the configuration files that are used to secure user environment. And the very first file that again comes up or jump out is the etc password. So what exactly an etc password file is? So all we know, it's a basic flat file. And etc password, of course, is a user configuration file. Now, next question comes into mind. What is a configuration file? A configuration file, all of them, first of all, resides in etc directory, which dictates how your system or applications should function or work. So if you're running an application, let's say SAP application or Samba application, all its configurations and the files that you could change can and be kept in etc directory. Similarly, if you are changing how the user environment function or work, you have to modify its configuration files. Next thing is about the meaning of etc directory. Where do we get the etc directory? What was the history behind it? Well, etc directory is actually stands for etc, where everything else would go. That's where actually back in the days during the Bell Labs, they have everything, all the developers putting the codes together in SBin and bin, and they were putting the configuration file all over the place. So there was no structured file system. So then they realized all the configuration files should reside in etc. So even though the name itself says etc, don't confuse yourself that etc is something or some directory that is useless. etc is the most important directory out of other directories in your system. So all configuration files in etc directory are editable and customizable. If you want your program or your system to function differently from other system or the way you want it to function, you would go into etc directory, and that's where your other program files are located, and you could go in, edit those files, and customize it. Now coming back to our etc password file, what's inside of that etc password file that we could customize to secure our user environment, because this entire topic is about security, right? So let's look at that file. So I have a picture right here. Of course, picture speaks 1,000 words, so I'm going to put that in there and I'll go over it. So if you look at your etc file, it has bunch of rows, and each row corresponds to each user account. So if you pick any row, that will indicate that row is created for that specific account. So in this example, I picked root. So root. So first, everything that you see in a row is actually separated by colon. So the first word that you see before the colon is the account. It's actually the user ID. So in this case is root. It could be IFSol or any account that you have created. Second, when you see X, which means password, meaning this account has a password, but of course you're not going to see it here. The password is encrypted for security reasons. Then 0 is the user ID of that user that is assigned automatically, or as a best security practice, you could change the user ID so it's not easily guessed. This fourth column is about the group ID. Third column is the user information, meaning anything that you wanted to put in, like a user description. Like if you have your last name you wanted to add in there. So sometimes, let's say if I have a user, let's say IFSol, I wanted to put in my full name as Imran Afzal, so I'll put that in this section. Then we have the home directory, which is /root, and for regular user it will be /home and the home directory, depending on the distribution, of course. And the last one is the shell. What shell the user should be using when the user logs in. So that's how the etc password file is looks like. So I'm going to log into my Linux machine and I will go over the actual how the actual file looks like. So let me go straight to my PuTTY session. I have this Linux machine logged in as root. I could also log in as PuTTY. So let me go in as PuTTY. So in the PuTTY section, I am logged in as myself. And now, if I make this a little bigger, I could do cat etc password, and you will see a whole bunch of users that I have created in the etc password, and some of them are pre-created during the install. So the ones, let's say if I pick my user account, which is right here, you will see the first field is my name, sorry, my username. Second is my password, which is always going to be X to as an encrypted password. Second is the user ID. Third is the group ID. Fourth is my description, name of the description, or anything that you want to type it in there. And then we have the home directory. When I log in, where is my space where I will land? And the last one is the shell environment, which shell I will be given in my environment. So this is about the etc password. Now you probably notice other logins as well. So for example, mail null or SMSP, or many others that do not have login. So what it means is when this user or someone comes in as this user, their home directory is this, but they will not get a login session. This is basically a script. If you run the script sbin /no login, you will see it will tell you this account is currently not available. So this is the exact message you will get if you try to log in as postfix or any other login. So there are other users as well. So let's look at other users. So what I'm going to do, I'm going to grep -v, which is the option to exclude some of the options. So I'm going to do exclude. Let me use egrep, which is a little powerful. I'm going to use egrep bash and then exclude no login. And from etc password. When I hit enter, you will see it has excluded all the lines that has bash, which we already discussed, all the lines which has no login, which we have already discussed. So the things that we have not discussed are these three logins. And you're probably thinking, there are three users. That is, one is shut down, one is halt. So let's talk about these two users. Why do we have account for these users? So there is a account for shutdown. It means when a shutdown logs in, it will be forwarded to a shell, and that shell is called sbin shutdown. So this is the actual command if you want to shut down your system. So you could become SU user, which you are right now, and you could type shutdown to shut down your machine. Or what you could do, you could log in as a regular person and you log in as shutdown. That will also shut down your system. Same way the halt works. Now about sync. If you want to sync from one machine to another, you could also log into other machine that functions pretty much the same way. So to wrap up this lecture, I would say please focus, please spend some time on this etc password. That's where you could define, where you could make changes to make your user environment more secure. Then next we will talk about how etc shadow file works, how etc group file works, and then you will have a better understanding in terms of securing our environment. Hello, and welcome to the lecture about PAM. What is PAM? PAM stands for Pluggable or Plug-in Authentication Module, which provides dynamic authentication support that sits between Linux applications or programs and the Linux native authentication system. So let me set your expectations here. PAM is not very easy to understand. The more you work with PAM, the more you will understand. what I will try to do here is to provide you as much information, as much foundational information or conceptual information about PAM. So this way you will understand how PAM works and why do we actually need PAM in our Linux environment. And of course, PAM is one of the main security tools that deals with authentication. So let's take an example. Let's say we have a server. Let's call it server A, and it has an application running. And let's say its application is Apache web server, or even let's say NFS or anything. That user that's running that application wants to log in to another server, and that server, let's call it server B. Now, in regular old days or regular way, it that authentication, when that service comes in, and that authentication will go to its local authentication. And as you know, local authentications are usually in etc password, etc shadow file. Now, what happened was the PAM was introduced because every application behaves differently. And if you want to have that application or that program or that service, anyway, all three of them are the same terms used interchangeably. If you want to have that application talk to the local authentication, you would have to modify that application every time it needs to talk to its local authentication. So what was done was they introduced this tool called PAM. So PAM has different modules inside that actually has built-in mechanism to talk to or to allow users or programs to log in to the server. The main purpose of PAM is to allow system administrators to integrate services or programs with different authentication mechanism without changing the code for the service. Again, what is that service? Service could be anything like NFS, um, it's VSFTP or FTP or Telnet or Apache, or even if you have a third party directory services like Active Directory or Winbind or LDAP. When you want to use those mechanism or the authentication to log into a Linux server, then you do not have to make any changes to those applications. What you have to do is connect your service to PAM in the remote Linux machine or the local Linux machine and tell that authentication service to go to the PAM module. And PAM module already has built-in algorithm behind the scene as to how to log in that service or that user. And then again, this way you don't have to deal with changing any codes on its on that program itself. There are many programs in your local machine system that uses PAM modules too. So not necessarily a remote machine application would have to log in to use PAM. You have programs in your local machine that actually uses PAM modules, and those are like SU, password, SSH, logging in to its own FTP server, logging in as a telnet to its own system. So if you are a regular user and you become SU, it actually talks to PAM module, and PAM module has the instruction as to when someone, a regular user, wants to switch user to another user or to a root user, for example, then what are the operations or what are the set of rules that we have to follow before we authorize that user to become root. Moving on, the configuration of Linux PAM can be done in two ways. You can either put everything in one single file, that is in etcpam.com file, or split the configuration by service in the directory with etcpam.d. So better to use the etcpam.d directory, because if you have a service or a program, again I'm using these terms interchangeably. As you know, program, tools, or service, they all mean the same thing. So if you are running that program or that application, it is highly recommended that you create the module or the configuration file in etcpam.d directory. Keep in mind, the Linux PAM will ignore etcpam.conf file if the etcpam.d directory exists. So there are two ways you could do. You could put all the set of instructions in pam.conf file, or you could create separate files into etcpam.d directory, which is highly recommended. If a service or a program does not have a config file in the etcpam.d directory, then it will use etcpam.d/other. That config file is already there, and it always comes pre-configured in your system. Important thing, that is something you have to remember. If PAM is wrongly configured, then you will not be able to log in to your system. Therefore, I will definitely recommend everyone to please take a snapshot of your machine or take a backup, or if you're making a change to your system, always log in to another terminal or through the console as root. So if you are trying to make changes to your PAM configuration file while you are trying, it does not work, and you logged off, and there are wrong configuration in those files, you will not be able to log into your Linux machine. Linux machines or Linux operating system are a very secure operating system. So it will not let you log in regardless how you're logging in. So keep a session open, or take a snapshot, or take a backup of your system before you make any changes to your etcpam.d/configuration files. PAM sends all its activity information to the two logs. One log is in var log messages, and the second one is in var log secure. The reason it does not output any error messages or any successful message on the screen, so if a hacker logs in, if a hacker sees that message on the screen, the hacker would know what happened, why it couldn't log in. Therefore, it will go into var log messages or var log secure messages. In the next lectures, we'll cover about how pam.d configuration files are configured. Again, to reiterate, PAM is used to log in system users or system services to your system for authentication. Also, it is used for third-party authentication. Again, if you are using LDAP, WinBind, or any other Active Directory related type of services, you don't have to make changes to that application. All you have to do is to go in and modify the PAM module libraries. And what are those? We'll cover that in the next lecture. Let's talk about the importance of PAM. Once you know why PAM is so important in the environment, then you will actually understand why PAM is needed. Or if you have any doubt in your mind still about the PAM, then this lecture should take care of that doubt. So let's take a quick look. You have a user in your machine. That user try to authenticate or try to log into a machine, a server, and of course that server is a Linux server. Now this is the regular old days, always been there like that. And what happened, the server, when someone tried to log in, that server will go into its etc password file and check whether the user who is trying to log in exists in that etc password file. If it does, then the next step is it goes to etc shadow file, and the shadow file has the encrypted password, and the password entered by the user who is coming in matches with that encrypted password. Then the server will allow the user to log in. Perfect, works beautifully. Now, this method is simple again, but yet bit clumsy. How? Each application requiring user authentication has to know how to get the proper information when dealing with a number of different authentication schemes. What it means is, if you have application, for example, again, let's talk about in this example, login itself is an application. If this application is coming in through a different authentication scheme, instead of putting in login username and password, let's say if it is coming in through RSA token, or if it's coming in through smart card, or if it's coming in through biometric means, or anything that all the time the new methods are emerging, what will happen? Then, of course, the server would have to know how to handle those requests. So for that purpose, the PAM come in. So again, as a new authentication schemes is built, the old ones becomes obsolete. In other words, if a system administrator, or you, if you are a system administrator or engineer, if you want to change the authentication scheme, the entire application must be recompiled. And the entire application are what? Like login, FTP, SU, SSH, all of those are applications. You have to, that program has to recompile to be compatible with the authentication examples as I have written right here. It says RAS, Smart Card, Biometrics as they changes. And as we know, every day we are trying to secure our environment. We are trying to make our environment more secure, and people and developers coming up with a more secured authentication schemes. So what will happen as they update, send a new release, or add a new authentication scheme, then you have to rewrite that or recompile that entire application. Again, those applications are like login, FTP, SSH had to be recompiled. So in that whole scenario, to avoid this recompilation of your applications, the PAM was born. So PAM solved that problem. Again, I'm sorry if I'm repeating myself in this lecture, but my whole intention is that you understand what is the purpose of PAM. As an example, let's look at the account access through PAM. What we have just learned in the previous lecture, we learned about the module interfaces, the first four of them. So let's take an example and see how they act as an interfaces when an account or a user try to log in. So login request comes in, or SSH or login or password, whatever that needs to be done, and it has to go through PAM. Now PAM knows that it is either asking login, SU, password, sudo, SSH, FTP, Telnet, Samba, Smart Card, RS, whatever the service that is being requested. What is going to do is it's going to put up the front cops out there, or the people that are actually at the gate to verify that this person or this user or this service that's coming in goes through this entire process. And that entire process is auth, account, password, session. So it has to go through all those checks before any of the services to the right are initiated or started or allowed to be accessed. So now this slide is pretty much related to the earlier slide we talked about, but this is more in an example in a figurative way, so it will be easier for you to picture how this whole module interfaces work. We are on to the third column, which is most of the time is the last column. And that last column is the modules. The modules are, in this example, I have highlighted them in green, and those modules are located in libsecurity, lib64/security. They are dynamically loaded modules. PAM loadable object files, the modules, are usually located in the following directories, which I have already talked about. Of course, it depends on the architecture as well. If you are using a different architecture of Linux that might not have the exact same location, then you have to look it up online to find out where exactly your module libraries are located. A module can provide mechanism to authenticate users from any backend like a file like etc password or database such as winbind, AD, OpenLDAP, etc. So that module or library has a kind of a mechanism built in by the developers. That library or that module knows how to talk to system or operating system to get access. And if you want to see the list of every module that is available, you could go into lib64 or libsecurity and you will see all those different modules. Most of these modules are pre-built and comes pre-installed with Linux OS distributions. The programmers or developers or administrators sometimes can also write new modules based on their application requirement. So if they have come up with a new application XYZ and that module has to go through certain checks, then that module can be built new. So this way, every time there is an authentication, the same scheme authentication is used, that module can be used with that program. Then the main module in any distribution is pam_unix.so, which is the one that allows you to log in, which is responsible to verify your authentication. That's the main one. Each module details can be pulled from man pages. For example, you could do man space pam_unix. You don't have to specify .so. It will give you all the detailed information of that particular module, what exactly it does. The fourth column in the file format of configuration file is about additional comments to choose, like close, open, force, revoke, anything that you want to add extra security parameters to that configuration file. Let me open up my Linux machine and we could try a few things to see how or where those modules are located. So as I said, the PAM loadable object files, the modules, are usually located in the following directories, and those directories are lib, security. So in this example, I think we don't have security, so we will go to lib64/security. Yep. Here, when you do ls, you will see all those modules ending with .so are the actual module that is used for each program. Same way, so you have a configuration file. Please don't confuse the module with the configuration file. You have a configuration file for an application, let's say SSH. That configuration file has a set of rules that tells that application whenever a user need access to the application, it has to go through that set of rules. And those set of rules is like the auth, the session, the account has to match, and the control flags is it has to be requisite, or required, or not, or sufficient. And the last part is about the module itself, which has the mechanism built in that actually tells the kernel or the operating system how to go through those certain procedure. So that's like a mechanism or an authentication mechanism behind the scene. You cannot view these modules. So if you do pam, let's say pam_shell so, you'll see it's coming up all garbage. So you cannot view these modules. These modules are encrypted. These modules are written by the developers depending on the programs that is being used. So let's say in this example, mk home directory. So if a user is trying to log into the system, and as one of the session or on when the authentication come to the point at account. Remember, the first one is auth, the second one is account. So when it comes to the account, we could actually put that module right in front of it to say required that they log in. We could put pam underscore mk home directory, meaning if the directory does not exist, create a home directory for that person or for that account. Same way, there are different modules. Again, if I go through every modules, it's going to take a really long time. If you wanted to learn about every module, you have to type man pam underscore mk home dir. Don't type .so. You hit enter. You're going to find the information about the module. It says pam module to create user's home directory. And it has all the information. So please do spend some time going through some of these modules, or some of this manual documentation. Let's try another one. Man pam underscore deny. This module is setting the locking out PAM module, meaning if a user, let's say, tries to log into the system and the user has tried 4 times or 5 times, upon the 5th try, lock that user or lock that account. So that module could be added to the configuration file, and the configuration file is right there, and you could put that module right here, meaning the session, the authorizations coming good, the account is not disabled, and sometimes the session is the one when you has to establish a session and you try to get a session the 5th time, it will lock it out. We could try one more. Let's say man pam underscore root. Okay, this is the one to gain only root access. So if you are trying to become root or trying to get access to the root user, then it has to go to the certain module, and the module has a way to put that user to the right direction. Also, as I said here, right here, the main module of any distribution is pam underscore Unix, which is responsible for logins. So if you do man pam underscore Unix, you'll see module for traditional password authentication. Meaning when you log in, this module will go into the etc password files. Usually, right here it says usually this is obtained from the etc password and the account shadow file as well if the shadow is enabled. And it has a lot of information. You could go through it, how each one of them is written and how they could work. Also, I think if you do man just pam, it will tell you what exactly pam is. If my way of explaining things how pam works was not comprehensible, then I would say that you could go through this man and read through what pam is, and this will tell you some of the more detailed information about the pam that probably I have not covered, but please do spend time going through it. So to reiterate, no, to go through it again, to rephrase what I just said, or I would say to just summarize it about all those columns. The first column is module, second column is control flags, the third module is the rules or modules, the mechanism behind it. So this is in regular example, the first column is like a people or the cops are standing there, what they need to check. The second one, the first column are the actual cops. This cop is a session cop, this cop is an auth cop. The second column is the one that what they need to check. So if they have to check your tickets, they have to check your ID, and if you have an ID, if you don't have an ID but you have a passport, okay, that is sufficient. So these are the type of rules that applies to that. And the third one, if all of these are met, then what needs to be done? And those mechanism is behind the scene to actually authenticate and allow access to the service. All right, let's talk about the control flags. The control flags is the second column in the configuration file. And if you see in the picture on the right hand side, you'll see the one that is highlighted in blue are the control flags. It is the second column, and we have 4 control flags in service configuration files. And as you know, the service configuration files are in where? At cpam.d. What are those control flags? Control flags, the first one is requisite. The strongest flag it is, and what it means is if a module interface is flagged as requisite, meaning if the first column, which is the module interface, is flagged as requisite and it fails the check, PAM will return to the calling application and report the failure. Second one is required. In the case of failure, execution is not stopped but continues to the next module. If after all the modules have been executed, one or more has failed, PAM will return failure to the calling application. Third one, we have sufficient. If a sufficient module returns OK, the processing of the module will be stopped. And the last one is optional. In the case of failure, the stack of modules continues execution and return code is ignored. There is another addition. In addition to above control flags, there are a couple of other control flags as well, which is sometimes used. And one is an include, and the second one is substack, which both mean the same, which means include all lines of a given type of the configuration file specified as an argument to this control. So if there is a file that is specified in the third column, then you will use the include control flag. Again, what is a control flag? Control flag is one tells you, okay, this has to be passed before you do that. Or if that does not work, then you go through this. Just like, again, as my example, if you are going through a gate and that has like 4 different security checks. The first check is requisite. When you pass that, then you go to the second one. When you go to the second one, you go to the third one. But they all interchangeably linked together. And they all have to be written in the configuration file with the proper order. And that order is always starting with requisite, require, sufficient, and optional. Similarly, the first column has to work the same way. It has to follow an order. An order is that first is auth, second account, third is password, and the fourth one is session. If you want to learn more about Linux, check out my best-selling course on Linux at udemy.com, or you could go straight to my website utclsolutions.com and you will find the exact same course there.